So this is 1 times 2 to the power of 4. It's going to keep increment, right? So this is going to be 1 times 2 to the power of 5. So it's the same principle of your decimal exponents, right? So it's increment from 0, 1, and 2, right? Same, this is from 0, 1, 2, 3, 4, and 5, right? So it's the same, if you have 1,000, it's going to be 10 to the 3. This is best 2, that's why we have 2. And then what we need to do is 2 to the 0 is what? 1, so 0 times 1. And that's going to be 0, right? 0 times 1 is 0. And 2 to the 1 is 1 times 2. And 1 times 2, 2 to the 1 is 2. 1 times 2 is what? 2. 2 to the 2 is 4, that's 1 times 4. And 1 times 4 is 4. And 0 times 2 to the 3 is 8. 8 times 0 is 0. 1 times 2 to the power 4 is 16. So 16 times 1 is 16. 1 times 2 to the power 5 is 32. 32 times 1 is 32. Now we just do summation of this. And we get the answer, which is we just convert from binary to decimals. Alright, so 32 plus 16 is okay. So 32 plus 16 plus 0, right? Plus 4 plus 2 plus 0. 54, right? So we get 54 out. Right? We said this out actually 54. So that's how we convert from binary to decimal. Now let's check 54. Alright, I just show you how do we convert from decimal to binary by divide by 2, keep tracking on remainder. Alright, we get this, right? And then I just show you when we get binary, I convert back to decimal. We just use this, right? These are binary, right? And use the exponents. And multiply by 2 to the exponents of each digit. And then sum them. Alright, so now, after you understand how to convert between decimal and binary, so decimal to binary, what do you do? Divide by 2. So it's going to be the same. Decimal to octa, you're going to divide by 8. You can just take 17 divided by 8, you get octa. And keep tracking on remainder. So let's say, for example, 17 and 8. So 8, how many times? 2, right? And remainder is 1, right? And 2 divided by 8, that you divide into, you get 0. Remainder is 2. So that's it. So 17 in octa is going to be 21. And exactly 20 and 21. And which is the same principle when you do convert from octa to decimal. You will do the same, but instead of base 2, you're going to do 8 to the 0, 8 to the 1, right? Like if I have 21, right? So you see that 1 times 8 to the 0, right? And 1 times, so I'm going to say 1 times 8 to the 0. And then the same 2 times 8 to the 1. So 8 to the 1 times 2 is what? 16. 8 to the 0 times 1, right? That's 1. So when you add them, you get 17. Okay? So that's pretty much the same principle here. So I just need to put that equals next to it and add. Okay. Alright, so this is for opt-out, right? Now, I just show you, for hexadecimal, it's the same principle. Instead of divide by 8, you just divide by 16. Take 17 divided by 16. You see that you get 1, remainder 1. Correct? Do I need to write down for you? Let's see. Example. 17 divided by 16. 1, remainder 1. Correct? And 1 divided by 16 is 0. And 1, 1. So that's why we have 1, 1 back. And the same, if you convert back, it's 16 to a 0 and 16 to a 1. You get 17 back. So let's take a look real quick then. So if I take 1, 1, so I'm going to have 16, right? 1 times 16 to the 0. And then 1 times 16 to the 1. And when you say 16, this will be, if I take 1, 1 here, right? So this will be the 16, and this is going to be a 1. So when you add them, you're pretty much going to get 17 back. Okay? So that's the same principle. That's why when you have 1, 1, you convert back, you get 17. So that should be it for number conversions. And if you want to know what character is, you have to look up ASCII table.